Welcome to Geometry Unit 5. This is the lesson on skill number 27. I can construct the circumcenter, incenter, centroid, and orthocenter of a triangle. We'll start our notes on page 05-06. Title it The Four Centers of a Triangle. As you can see on this page, I have created 4 fold-out little notes, one for circumcenter, one for incenter, one for centroid, and one for orthocenter. These are the 4 centers of a triangle, and in today's lesson we're going to learn how to find those 4 centers. First up we have 2 vocab words. First one is when 3 or more lines intersect at one point, the lines are said to be concurrent. And the second vocab word is the point of concurrency is the point where concurrent lines intersect. Alright, first we're going to fill out the inside of circumcenter and circumcenter and centroid. So the circumcenter is the point of concurrency of the triangle's perpendicular bisectors, and the centroid is the point of concurrency of a triangle's medians. The incenter is the point of concurrency of a triangle's angle bisectors, and the orthocenter is the point of concurrency of a triangle's altitudes. So there's a couple words that we haven't learned, medians and altitudes, or maybe we learned them previously, but we'll get to those later today. For this skill test, we will need to be able to construct with a compass and straight edge or ruler these 4 triangle centers. So I have outlined notes on how to find each of these centers. Page 05-07, we are finding the circumcenter. And the circumcenter is the point of concurrency of the perpendicular bisectors. So we need to draw perpendicular bisectors. I'm not going to show you in this how to do it. We'll do it in class. But first, a brief summary. To find a perpendicular bisector, and please don't write this down yet, what you would do is you find the midpoint of BC and then the line that runs perpendicular to that midpoint. So that is a perpendicular bisector. Perpendicular for AC and the perpendicular bisector for AB. So if my drawing was accurate, that would be the circumcenter. A few subtle notes about circumcenter is the circumcenter is on the inside of an acute triangle. It's on the outside of an obtuse triangle. So the circumcenter of this triangle might actually be outside of it. And then on a right triangle, the circumcenter will actually occur somewhere on the hypotenuse. The circumcenter allows us to circumscribe a circle around the triangle. So if this was our circumcenter, we would be able to make a circle with that as the radius in such a way that it touches all 3 points of the triangle. That is circumscribe. To construct the incenter, we're going to be finding angle bisectors. So what we would need to do is find a way to bisect angle A. It's probably somewhere around there. Bisect angle B is probably something like that, and bisect angle C is probably somewhere around there. So the incenter is right there. And the incenter is always located inside the triangle. Incenter inside the triangle. The other cool thing about an incenter is it allows us to inscribe a circle inside the triangle, which means if this was our radius, we would have a circle that is inside the triangle that touches all three edges. We'll do this construction in class. Page 05-09 is how to construct the centroid. First, to construct the centroid, we need to know what the median is. And a median of a triangle is a segment whose endpoints are the vertex of a triangle and the midpoint of the opposite side. So we'd move from vertex to midpoint. We'd move from vertex to midpoint. And finally, we can move from our other vertex to our third midpoint. This is called the centroid of the triangle. The centroid is always located inside the triangle, and the centroid of the triangle happens to also be the center of mass for a triangle. Once again, we will find these in class using a compass and ruler. Page 05-10 is constructing the orthocenter. The orthocenter relies on us knowing what an altitude is. So an altitude of a triangle is a perpendicular segment from the vertex of a triangle to the opposite side. Perpendicular. So that is roughly an altitude for that vertex to this side. Oftentimes people see the altitude being used to describe the height of a triangle. And we will again construct this one in class. So that wraps up the notes on this skill. We will have a skill test on skill number 27, geometry skill 27, where we will need to do 4 constructions. So what I mean by construction is we need to use a compass and a ruler to find the 4 centers. Who knew a triangle had 4 centers? Thank you.